Alright, today we have topic 3.1 angles. And in this topic, we will define an angle. We will properly name an angle. We will learn the proper syntax to name an angle. We will learn different parts of an angle and different types of angles. Also, we will learn whenever you're giving information about a particular angle, how we can use that information to solve for information asked about another angle. Alright, so let's begin with the definitions at the top of our topic 3.1. We have two definitions. One we should already know. We should already know what a ray is. A ray is an object consisting of one endpoint and continues infinitely in one direction. We should already know that from our previous units. Ray is an object consisting of one endpoint and continues infinitely in one direction. Now, an angle is an object consisting of two rays. Two rays, and we're going to call these rays, what you will hear them referred to as sides, the sides of an angle. They are really rays, but I'm sure everybody is familiar with hearing the sides of an angle. And they have a common endpoint. Common endpoint. Now, you may not know what these are commonly referred to, but we will be calling those the vertex. So an angle is an object consisting of two rays, which we call sides, with a common endpoint, which is called a vertex. So now let's look at our example 1. Example 1, we have an angle drawn up here, angle ABC. And it's asking us to name the sides. So if we're going to name a side, we're going to look at our two rays, and we should name these rays accordingly. We have a side, a BA. We draw this, close the end on the B and an open arrow over the A. This must be drawn correctly. And then we start with the end point of the ray, so we also have a side of BC. Make sure our syntax is correct on how to draw the ray. Now, a vertex is just a point, and that's our two endpoints that they share, which we're looking at right here. And if we're just going to name a point, we use the capital letter of that point, which is B. Now, in order to name, when we're asked to name an angle, we have this little angle symbol right here, and we're going to use all 3 points in most cases. In most cases, you're going to want to use all 3 points. We're going to start with an outside point. Our middle point must be our vertex. So as an example, right here we have A, B, C. So we have angle A, B, and C. Now also we can name this another way. We have angle. We can start with the other direction. C, B, A. It must have our vertex in the middle. Maybe you want to put that in as a note. Vertex must be in the middle. Now, another way of naming this, if you have a simple angle that we're looking at right here, it doesn't have any additional parts. If you just take a quick glance down to example 2, you will see what I mean by additional parts. It has a whole nother ray mixed in with this. We can also name this angle B. Angle B. We'll just use our vertex to name this angle. Now, real quickly, I'm going to go ahead and we're going to work example 2 as a group. Example 2, I have an angle here. I have our diagram. Excuse me. And it's going to ask, how does the diagram in example 1 differ from the diagram in this example? Well, real quickly we can see that there's an additional ray. Now what does that create with this? In this instance, if you look up at example 1, you have one angle. But here, how many angles can you count? Well, a lot of times people will look and they say, well, here's one angle, here's two angles, but then you also have every bit of this from here all the way over, and that is going to create our third angle. We have three angles. So how does it differ? You have, and you can simply write this, have three, I'm going to abbreviate my angles. And let's look at naming them. This is where I was talking about our names come in. If we're going to name these, I'm going to name them real quickly. We have angle QPS. Another angle, we have RPS. And then lastly, we can have a QP and then R. And if I was going to associate with the numbers that I've drawn over here, this would be my first angle, RPS would be my second angle, and this would actually be my third all the way around. But what you cannot do, if you want to write this down, you cannot say simply angle P. We cannot say that because we have three different angles in this. It's whenever you say angle P, which angle are you talking about? Are you talking about 1, 2, or 3? So we cannot just simply say angle P because that is not going to tell us clearly which angle we are talking about in this instance. So let's look right down below that, and it talks about an angle separates a plane into three distinct parts. So we have three parts. Our first part, pick a color for that. Our first part is going to be interior. Our interior. And our interior is what's dealing with, let's say we take PQ and, well, let's take PQS. Let's take this whole thing. This right here will be our interior. From one side to the other, looking at what we have in terms of an enclosure. Let's put it that way. It's an enclosure of this angle. So anything that is in between these two rays would be considered our interior. Now our exterior is our second part, exterior. Now that is talking about anything that is on the outside portion. Anything that will be on this outer portion from here around to that part. And let's see, lastly, we have, let me grab another color. For our third part will be dealing with stuff that is on the angle itself. Now that is not an L, that is standing for angle, but that is for the angle itself. So we have three parts: the interior, which I have drawn right here, the exterior, which will be anything on the outside if we're dealing with QPS, and then we have something that is on the angle that itself, which could be any point along these lines, like what I'm drawing right here, any of these points, any of the points that actually be used to name the angle. Alright, so go ahead and work A and B for example 3. It's just going to ask for an interior and an exterior point. And then we're going to actually look at the angle addition postulate. Now this postulate states, and let me pull up a diagram that it shows here. It says if R is in the interior of angle QPS, then the measure of angle QPR plus the measure of angle RPS equals the measure of QPS. So if the measure of QPR plus the measure of RPS equals the measure of QPS, then R is in the interior of QPS. So let's look at basically what this is stating. This is stating, and it tells us here that the measure of QPR, let's put measure of angle QPR. We're going to refer to that as 1. So QPR is our 1 right here. That's right, this measurement. And then we also got the measurement of RPS. I'm going to refer to this as 2. So the measure of angle RPS, we're going to refer to that as 2. We're going to say that is all equal to, grab another color here, all these two things, when you add them together, 1 plus 2, you're going to equal our measure of angle QPS being all three of these. We can say that is our third part. When we add them together, we add this section and this section, obviously we get this section. So if we can say that this is true, then we can say that R, our point R, is on the inside of that angle. So let's look, I'm going to let you look at example 4, and we will move on to example 5. Alright, so let me remove this and let's pull up where I have example 5. Example 5, you have an angle, a pair of angles that look similar to this up here, and it says if the measure of AOC, so I'm going to put measure of angle AOC equals, and it gives us 70 degrees. 70 degrees. So I'm going to go over here, I'm going to find AOC. This is our entire thing. We know that every bit of this, from here to here, 70 degrees. It also gives us the measure of angle AOB. I'll change different colors of that. Measure of angle AOB. And it gives us that it is an X plus 10 degrees. Now all this is in terms of degrees. All angles are measured in terms of degrees. So, or well, radians later on, but for geometry purposes, we'll go with degrees. Now this angle right here, it tells us is X plus 10. And then it also will talk about, let me find my place here, BOC. BOC, I'll leave it right here, measure of angle BOC, and that is equal to simply X degrees. So then we have this angle right here, which is X degrees. Now, we've got to solve it. It wants us to find what X equals, and it also wants us to find the measure, the actual measure in degrees of angle BOC, and then it also wants to know what the measure of AOB is. First, we have to solve for X. Anytime that we have a variable involved, we need to solve for that variable. Now, in order to do so, we know that the interior angles, these two interior angles, will add up to our exterior, just like before. So we can say our X plus 10 plus, we have an X here, will equal our whole, those two will add up to our whole angle here, which is a 70. So let's go ahead and work this out. We'll solve for our X. X plus 10 plus X equals 70. We have 2X plus 10 equals 70x. Oh, wait, I'm sorry, a 2x. I'm going to subtract 10 from both sides. Subtract a 10. Subtract a 10. 2x is equal to 60. Divide both sides by 2. We will determine that x is equal to 30. So we can come over here, we can say x equals 30. Now it wants to know the measure. Now as we're talking about measures, this x is just 30. That's fine. Now this will need to be in degrees. VOC equals x, so we know that we can say it is 30 degrees. Make sure you have the symbol. We need the syntax correct. Now the measure of angle AOB is an x plus a 10. So I'm going to come down here, I'm going to say x plus 10. I'm going to put in my 30. My 30 plus 10 is equal to 40. So we have 40 degrees here. Now if we add these two together, 40 plus 30, that gives us our 70. That is our check step. So we know that that is correct. Alright, now let's turn the page and let's look at the classifications of angles according to their degrees. If an angle has a degree measured less than 90, it is classified, and as many of y'all may already know, that is going to be an acute angle. An angle less than 90 degrees. If it's equal to 90, it is a right angle. If the measure is greater than 90 degrees, we're going to classify it as an obtuse angle. And lastly, these are angles, but if it is equal to 180 degrees, then it is a straight angle. A straight angle also, you can look at that as it's in a line. It's going to be a straight line, 180 degrees. We're going to classify that as a straight angle. Now, as real quickly, I'm going to work a couple of these examples from example 6 to make sure that we've got it correctly. We've got the first one, which is the 35 degrees F. You've got an angle at F. We've got points Y and I on this. It's going to ask us to name it. So if we're going to name this, we can say angle. Start with one of our points, vertex. So we have angle YFI, and then it has an or, so since we don't have any other angles going off of this, we can say, or we can just call it angle F, angle F. The measure of angle F, well, it gives it to us real simple right here, 35 degrees. Since our measure is 35 degrees, we're going to classify that is less than 90. So this will be an acute angle. And now the next one that I'm going to work with y'all will be the last one, bottom right. We have an NXS. It is all on a straight line. So if I'm going to name it, I'm going to, let me grab a different color here. We have an angle, because remember these aren't angles. We'll start with our NXS. X is in the middle, just like if you took this one over here and we laid this completely flat, we have to keep our X in the middle. We can also name this as an angle X. Alright, our measure of such, it's a straight line. Any straight line measures to be 180 degrees. Now if we're going to classify that, if it is equal to 180 degrees, this will be a straight angle. Alright, so now let's move to our next page where we've got a definition. Our next page, at the top it actually says when angles have the same measure, they are said to be congruent. Now, it is important, I'm going to write this down. We've got, find an area for it, congruent. I'll put it right up here, congruent. Now whenever things are congruent, we will use a certain symbol to define congruent, and you'll see this from here on out. The symbol, if I can get it correctly here, little squiggly with two lines underneath, that is congruent. That means they are equal to each other. So an angle bisector. We already know what a bisector should be, so let's look at it. And for an angle, it is a line, ray, or segment that defines an angle into two congruent, let's see, let me put this down here, two congruent, I'm going to use the little symbol, angles. So it's going to cut it directly in half. One angle will equal the other angle, and we will call those angles congruent. So if I'm going to come over here and quickly draw example 7 out for us. Put an attempt to it here real fast. And we have points for example 7. 3 points on this. We have W, Z, Y here. W, Z, and a Y. And our vertex for all three is X. Alright, if XZ, if ray XZ, I put my ends on this, that way it will be shown as a ray. If ray XZ is a bisector of WXY, name the two congruent angles that it forms. So if we know that, and this is how you're going to see it labeled, you will see right here, you'll see these angles with our lines through them. Those are showing that these two are congruent. So if we're looking at these two angles right here, we have angle WXZ, and we're going to say that it is congruent to angle ZXY. Now you can also name that YXZ. It is, and this can be ZXW. Doesn't matter as long as you properly name them, starting with an outside point, going to the vertex, and to another point on that angle. And let's see, what else do we have? I'll let you work example 8 by yourselves. Now if you're struggling with 8, example 9 should help you out. We're going to go ahead and look at it real quickly. I have a diagram similar to what you see up above. It says that ray FG bisects EFH, and then it asks you to find the value of X for each of the following. Now example 9 I have written here, measure of angle GFH is equal to 3x plus 20 degrees. The measure of angle EFH is equal to 4x plus 80. So if I was to redraw this, down below, which I will say time and time again is the best practice for being able to see what you're working with, it tells us that, let me put my points real quickly. Here we have a G, F, E, and lastly H. What it tells us is GFH is, we have here 3x plus 20. And then it tells us that EFH EFH. So this entire thing from here to this point is all equal to a 4x plus 80. I put our parentheses here because this is in degrees. If we look here, we can see our congruent. We have two congruent angles. Our EFG is actually congruent to GFH. So we know that this angle here, put this in a different color, this angle equals our other angle. These two are the same. They're congruent. So if we're looking for this entire angle, this will be the sum of these two angles. So I can come over here and I can say my GFH, which is a 3x plus 20, and I'm going to add another 3x plus 20 because they are the same. We're going to set those equal to our entire angle, which is a 4x plus 80. I add this, I forget my addition symbol there. Alright, so I'm going to take these out of parentheses and work it accordingly. We have a 3x plus 20. I need to change this right here. Plus another 3x plus 20. I keep wanting to put a 10 here for some reason. Plus 20 equals 4x plus 80. Combine like terms. 6x plus 40 equals 4x plus 80. I'm going to subtract 4x from over here. Subtract 4x from this side as well. I'm also going to go ahead and subtract 40 from both sides. That way we can quickly move this over and say 2x equals 40. Divide both sides by 2. That will leave you with x is equal to 20. It just wants you to solve for x. So at that point, you have your final answer.